about physical properties and chemical properties, we come to another example problem to kind of dissect, decompress, to digest mentally everything that we have talked about so far. So if you are watching this lecture from, like the actual lecture from beginning to end, please pause the video, kind of dissect and think about how would you identify the following actions? Would they be physical or chemical changes? If in the future you would like to return to this example problem, this is going to also be extracted and uploaded as its own separate video, so that way you don't have to scrub through the lecture to find this again in the future. So if you are watching the extracted version of this example problem, hi and hello. Please keep in mind that this follows up from a lecture, so if you would like more context for this example problem, please feel free to find the link to the overall part 2 lecture that this comes from. We're talking about properties of matter in the description/comment section below. Alright, so if you are still listening, I am assuming that you have already paused the video and we are ready to continue moving forward and talking about how we would define these processes as either physical changes or chemical changes. And remember, the bottom line is, does the substance over the course of this process change? So if you're looking at a physical change, your substance does not change. I'll say does not change chemical composition. That's really like the full caveat. Chemical composition. All right, if the process is a chemical change, your substance will change chemical composition. So formulas will change, atoms will move around, etc. All right, so melting. This is our first example. As something melts, by definition, we are going from an object that is a solid and it is turning into a liquid. All right, so S for solid goes into liquid. I wrote the whole word out here. So if something is going from a solid to a liquid, it is like the reverse of the example that we talked about previously when something's going from liquid to solid. So a really good example is just that of water. If we're looking at ice melting into liquid water, the chemical formula for ice and water is the exact same. And because we did not change chemical composition, yes, we changed form, but we didn't change chemical composition, the process of melting is known as a physical change. All right, so I'll draw a little line kind of distinguishing melting from the next example, which is rusting. All right, rusting is a corrosive process, right? The most just classic example of something rusting is iron turning to rust. And so you might ask yourself, what is the chemical composition of rust? Because that really is like a piece of information that's necessary to distinguish or decide whether or not the process of rusting is known or would be classified as physical or chemical change. Well, the chemical formula of rust, if you were unaware, or if you didn't rely on past experience or instinct, the chemical formula for rust is different than that of classic iron. It is Fe2O3. The rusting of iron is what is known as an oxidative process. Oxidative in the classic sense, meaning that we are adding oxygen into the chemical formula of the substance we are working with. So the process of rusting, since we did change the chemical formula, we did change the chemical composition over this process occurring, is going to be defined as a chemical change. Draw a line down the middle. All right, next up, we have drying. This is a strange thing to think about, right? It's not taking a substance and turning it into a liquid or from liquid to solid. Instead, we are taking two things that were mixed together, one thing that was wet. So let's say your skin, this is your skin, and there's just a bead of water sitting on top of it. So this is H2O. Well, the process of drying is really just separating the water from, in this example, the skin, right? If you want to dry your skin, you remove the water. In doing so, you don't change the chemical composition of your skin, and you also don't change the chemical composition of the water. Either you're drying it by air or you're drying it by towel, but all you're doing is taking the water and separating it from your skin, right? Water's over here now, skin is over here, your skin is nice and dry, smiley face. Well, the process of drying is just separating two things, where one of those two things happens to be a liquid. But the chemical composition of these two things has not changed. They've just been physically separated by space. Because we did not change the chemical composition, the process of drying is known as a physical change. All right, and last but not least, aging. This is a strange process to think about. If we imagine the aging process, right, generally we can, at least when it comes to humans, think about like, oh, you start as a baby, you grow up, you then get old. But where are the chemical formulas in this? Like, is this a process that can be defined as a physical or chemical change? And the answer is yes, because your body is made of matter. It's made of chemicals. Your body, as you start very, let's say, young, you then grow up, you then get old. So here's my older person. They have a cane here. Your body is changing form. And we may not have one cohesive chemical formula that represents the body, but we do have many smaller pieces that do build your body. Right? We have like cells in our tissues, and the cells can be even further broken down into the atoms that are inside of them, the molecules that are inside of them, things that can be represented like DNA, proteins, etc. And as you get older, your DNA changes. As you get older, your proteins change. Overall, if we're thinking from the chemical perspective, you are changing form over the process of aging. And if we really want to get down to the technical details, the reason why you change physical form is because the molecules inside of you are also fundamentally changing. They're either proportion or the physical construction of them, full stop. And so the process of aging we can define at the most simple level as a chemical change. Right, it's just something strange to think about. You don't normally think of your own body as being made of chemicals. I don't know, maybe you do. I do a lot. But it is, right? You are a physical object. You are a person. You are unique and you are made of matter. Your own chemical signature is separate from everyone else's, but one thing that we all have in common is that we all will still go through the process of aging.